Hey everybody, welcome back to 8th grade algebra, Unit 8, Lesson 3, where we're going to be discussing key features of quadratics in context. So before we get into today's lesson, I wanted to talk briefly about where we've been with our previous lessons. Previously, we learned how to factor in order to find the zeros of quadratic functions. We learned how to find the vertex, we learned how to make accurate sketches, and we learned how to completely describe the features yesterday. Today, we're going to be talking about parabolic motion. Parabolic motion is the motion of an object that follows the path of a parabola. Now you may notice I'm wearing a hoodie today because we're going to be talking a lot about basketball. I don't know if you like basketball, but I do. You also notice I'm wearing a blazer because I like to keep it professional. So before we get started with what we're actually learning today in detail, I wanted to introduce you to a couple basketball players who you may know. The first is named LeBron James.
My goodness. To the rim, it counts, and the foul! LeBron James with a sensational move. James up and under, throws it off the backboard. Oh, what a perfect pass to himself. How about this play by LeBron James?
That's LeBron James with authority, and they're standing here in Miami.
1-1. Here's McGinnis with the high dribble return. James. Yes, and the foul. Shot for LeBron James. Oh, my. Different way to score.
Bad LeBron, thanks. One thing you probably noticed is that LeBron James is incredibly strong. In fact, if you try to take him on anywhere in the paint, meaning anywhere close to the basket, you have pretty much no chance. But there's another player out there who might have a chance against LeBron James, and that player is Stephen Curry.
To go. Curry with Paul on him, and Reddick right there, forming a wall. Even if it goes in. Oh, and it did, but it will not count. Weaving, trying to get the shot up. No call that way. Curry flings it the other way, and he got it! What a turnaround! Curry the three! A miraculous shot.
2 seconds to work with. Curry from midcourt. It's good!
Pretty impressive, right? Now I should say, when I say that he understands parabolas, I really mean he knows parabolas better than I do. And that means he knows the exact path that each one of his shots is going to take. He knows how high it needs to go, meaning where the vertex needs to be. He knows the amount of time it's going to spend in the air. That would be the domain of this function. He knows all of that on a level that I can only hope to get at one point. So when I say that he understands it, I can't teach you what he understands. Only dedicated practice can do that. But today I can help you to describe what it is that he knows intuitively. Let's get into it. So today's aim is to interpret the key features of quadratics from graphs in real-world scenarios, mostly involving motion that follows a parabola. A couple terms you're going to want to be familiar with. One is a quadratic function, which is a function where the highest exponent is 2. It's the x squared term. Second is the parabola. That's just the shape that it makes, the U-shaped curve made by graphing a quadratic equation. The domain is all the values of the independent variable, usually x or t for time, for which the function applies. And then the vertex, as you know, is the highest, the maximum, or the lowest, the minimum, point on a parabola. All right, so here's the agenda we're going to follow to get there today. First, we're going to talk about Professor Splash. I'm going to explain some key features of these quadratic equations in the context of a new video. Then we're going to actually give you a chance to practice with something called the toy rocket. You will not actually be playing with a rocket today. Then you're going to check your work with a toy rocket, and then I'll send you off to practice. It should be fairly straightforward. All right, let's get into it. So first, I'm going to have you watch a quick video from America's Got Talent about somebody who understands parabolas so well that it has in fact saved his life multiple times. Check it out.
Wow!
Pretty impressive, and not something I recommend you try at home. So here's an equation and a graph that helps explain what we just saw from Professor Splash. Take just a second to digest what this is saying. Okay, now I'm going to ask you a question, and I'm going to ask you to enter your response in the chat. What is the y-intercept? So what's the value of the y-intercept? And what does it represent in the context of this video? Go ahead and type that in the chat. Your teacher will pause, call on somebody to explain, and then come back when you're ready. Great. What I got for the y-intercept is, first I said the y-intercept is when x is equal to 0. So I substituted 0, negative 4.8, times 0 minus 3 times 0 plus 2. I calculated it and got 28.8 feet. And what that represents here is the height of the platform. That was the starting height of Professor Splash before he started his jump, or right when he started his jump. Now, I'm going to ask you another question. What are the coordinates of the vertex? Go ahead and enter this in the chat. Your teacher will call on somebody, and you'll bring it back. All right, so here's what I got for the coordinates of the vertex. I knew that this had zeros at 3 and negative 2. It had a vertex then halfway between those, or at the mean, at 0.5. Substituting 0.5 for x, I got negative 4.8 times 0.5 minus 3 is negative 2.5 times 2.5, and that equals 30. So the vertex of this function is at 0.5 comma 30. But now I'm going to ask you in the chat to say, what do the 0.5 and the 30 represent? You're going to type the 0.5 represents blank, and the 30 represents blank. Hit enter. Your teacher will call on one of you to explain why, and then we'll see how you did. Here's what I got. I said that the highest point was at x equals 0.5, and I know that x is the time in seconds. So that means the highest point that Professor Splash reached was half a second after he jumps, 0.5 seconds. And the 30 represents the height, so it means he reached a maximum height of 30 feet. Okay, last question for you about Professor Splash. In the chat, what is the domain of this function? And I'm going to ask you to use interval notation like we've been doing. Go ahead, your teacher will call on somebody and we'll bring it back. All right, so I got that the domain was 0, 3 inclusive, meaning that 0 is part of the domain, right? He hasn't started jumping yet, but it's right there at 0. And that it ends at 3, meaning past that point, this function actually does not apply. If it did apply, that would mean that Professor Splash would have had a very unsuccessful jump, and he would have continued going through the ground into negative distance above the ground. And that didn't happen in this video, thankfully. So the domain here is from 0 to 3. Similarly, if we look at values to the left of the y-axis with negative x values, it doesn't make any sense to say where was he so many seconds before he jumped, because this function would not apply. It's not like he was climbing at the same rate and then went back down. Okay. So we now know just about everything we want to do. I'm just going to ask you one final bonus question. I'm going to ask you to put in the chat, over what interval of time is Professor Splash falling? Notice he's not falling right at the beginning. What is the interval where he is falling? Enter it in the chat. Your teacher will call on one of you and we'll bring it back. So I noted that the function is decreasing from this point in the vertex all the way to the end. And so Professor Splash is falling in that same interval from x is 0.5 all the way down to 3. Now he's not falling at 0.5 seconds. He's momentarily not rising or falling. He's kind of stuck right there. And then he comes down. So all the way from 0.5 just after it, that's why we have an open bracket, down to 3 seconds. And I would say he is still falling when he reaches the ground. We could debate that if we want, but that was my interpretation. So this is how I would write the interval that he is falling. At this point, we've seen just about all the types of questions that we're going to be able to answer in terms of taking what we know about quadratics and putting them in the context of this problem. Now I'm going to ask you to practice. I'm going to show you a problem or a situation, and you, in your classwork, are going to try to come up with all of the explanations like we just did on your own. This will likely take you about 7 or 8 minutes, and then we're going to bring it back and I'll show you what I got and how I got it. Here you go. So we have a toy rocket. It's launched from the ground straight upward. The height of that rocket above the ground in feet is given by the equation h of t is equal to negative 16t squared plus 64t, where t is the time in seconds. Okay, take it away. You're going to do this in your classwork, and then we'll bring it back as soon as you're ready. All right, everybody, I'm about to show you the work that I did. While I'm doing that, I want you to keep your Google Classroom document open so that you can modify your work as I'm explaining. That way you'll have something to go back to when you're working. Your teacher will check later also to make sure that it's right. I'm going to share with you just my thinking here. So you can see on the screen the work that I did. First, you can see that I sketched this graph the best that I could. You'll notice that's not what it ended up looking like, but I just wanted a general sense to see that, oh, there was going to be a maximum point here. Then I factored this. That helped me to find the zeros. And that helped me to make a more accurate graph. You'll note that at this point, I looked at the domain and said, well, it actually didn't start before I started the timer, so it doesn't go beyond t into the negatives. And it also didn't continue underground after the rocket came back down. And so after 4 seconds, the graph just stops. Then I started answering the questions that were asked here in my Google document. And so I said, 1, the y-intercept is at 0, 0. At 0 seconds it started and the rocket was on the ground. So that's what it meant. It meant that the height was 0 when it started. It was on the ground. Number 2, the vertex was at t equals 2, which is halfway between the zeros of 0 and 4. And then I found the y-coordinate of the vertex, h of 2, by substituting 2, and I found it was 64. So what does that mean? It means that the highest point of the rocket came 2 seconds after it was launched, and that at that point it was 64 feet off of the ground. I then went on to the third question, the domain, and the domain is from 0 to 4. T goes from 0 to 4. I almost put X. The rocket is in the air for a total of 4 seconds. So it starts climbing at 0 seconds, and it lands at 4 seconds. So that's all that the domain tells me. It's from 0 to 4, meaning it was in the air from 0 to 4 seconds, a total of 4 seconds. All right, here's a problem you might run into. Let's say that you've tried to factor something and you just can't figure it out. Well, there are still ways to determine the key features using technology. So here I am at desmos.com. I'm going to enter the equation that I'd like to see. You'll see this is one of your equations from your practice today. And now, when I hit enter, it's graphed, but I can't see it, and you can tell I can't see it because look at the scale here. And now look at this 150. So that 150 tells you that's the y-intercept. We're not going to see it yet. So we back up, we zoom out, and there it is. All right. And if we want to know where the vertex is, all we have to do is we have to click somewhere near the vertex, and Desmos will automatically show us where it is. In this case, 5, 155. And then you could determine, based on the context of the problem, what that means. You can also see the y-intercept, which you knew, and you can find the roots. These are the roots, 32.839 and negative 22.839. Huh. Well, no wonder I was having trouble factoring this one. All right, guys, hope this helps. Take care. And that's it. All right, everybody, I hope this was helpful. I'm going to send you off to practice a few more examples just like this on your own. Your teacher's there to help you out. And as always, I'm there with you in spirit. Best of luck. Have fun. Bye.